Hello everyone, today we are going to continue our conversation about similarity, and today we are going to discuss how we prove triangles similar. So the first question, I want you try to recall the memory of proving triangles congruent. In previous unit, we discussed 5 methods to prove triangle congruent. And if you do remember, there are actually the way we call this is SSS, SAS, this kind of thing. And 5 ways to prove the triangle congruent. Then today, since we're talking about similar triangles this unit, we also have methods to prove triangles similar. Then you may wonder, how many methods can we prove triangles similar? So there are actually 3 ways. So you may wonder why there's a less ways. So let's check each method here to see what are the differences compared to proving triangles congruent. So very first one, the definition is if 2 pairs of corresponding angles are congruent, then 2 triangles are similar. Very simple, straightforward. So all we need, if we need to prove the 2 triangles similar, we just need 2 pairs of corresponding angles congruent. So if we check this 2 picture here, there's 2 triangles, one is bigger and one is smaller. So if, according to the definition, if angle A is congruent to angle D, that's one pair, and angle B is congruent to angle E, that's another pair. Then we can come to the conclusion, triangle ABC. Remember, we still have to make sure the angles match it to each other. So A is matching to D, so I'm going to write down DEF to make sure each angle is matching to its corresponding angle. And remember, this is similar, so we do have a symbol for similar, as I mentioned in previous section, which is like lie down as. So it's a little bit different from the congruent symbol. We do not have the equal sign on the bottom. So that's what we said, 2 pair of corresponding angle. That's one pair of angle, that's another pair of angles. So that's why this method we called AA. Just because we call similarity in this chapter, in this unit, so that's why we call AA similarity. So that's our first method. So before we introduce the second method, I want to have a quick review regarding the word proportional. So in this unit, we mentioned the very first term we introduced is actually proportion. So it's very, very important term to understand similarity. So what does that mean? As we mentioned, that means have same ratio. So for example, I'm talking about the ratio between the girls and boys in class A compared to class B. If they have, for example, 3 to 5 as a first class, and second one has 6/10, so the second class have the girls to boys, the ratio is 6 to 10, so we know they are proportional. What does that mean? These 2 ratios are equivalent. As you can see, 3 times 2, 6, 5 times 2, 10, they follow the same pattern. So when we simplify, it will be equal to each other. So that means proportional. So let's check the next method. So this one says, pay attention to the keywords in the definition. 3 pairs of corresponding sides are proportional. As we mentioned, meaning they have the same ratio. Then 2 triangles are similar. So in this drawing here, I show 2 triangles with all the measurement of all sides. So let's quickly check what are the corresponding sides and how do they match to each other. So this time, I'm going to use a color to show the matching sides, but remember they are not congruent. So for example, let's use a blue one. So this is the matching size 10 to 15. and 8 is matching to 12. Last, let's use green. So 6 is matching to 9. The reason I want to use different color, I just want to show you the corresponding size. So the keyword here, corresponding size. Okay, now let's write down, let's figure out what's a ratio to the corresponding size and how, can we really prove they are actually proportional? So we have 10 over 15, that's the first ratio, 8 over 12, 6 over 9. So if we pay attention to the ratio here, you find everything I simplify. So for example, I'm simplify divided by 5, so this one will be 2 over 3. And if I divide by 4, it's going to be 2 over 3. And if I divide by 3, you will notice that it's also 2 over 3. So all the ratio, check this, all the ratio are equivalent to, when we simplify, even the first time we write down number, they're all different, but when we simplify, they actually equal to the same ratio. So that means all the ratios are congruent. So I can write down 10 to over 15 equals to 10, 8 over 12, 6 over 9. So that means they have same ratio. That means we can come to the conclusion they are similar. So let's write down the final conclusion here. So if, let's write down the corresponding size having the same ratio, AC over DF equals to BC over FE. So some student might wonder, can I write down CB? It's actually the same thing, doesn't matter. And then equal to AB, the last pair. So this one, then we can come to the conclusion. Remember, do not forget they have to match. So ABC is similar. So this time, the little curve sign here meaning similar. Please make sure you use an accurate symbol. So DEF. Then this time is, as you can see, we use 3 pairs of corresponding size. That's first pair, second pair, third pair. So that's why we call SSS. So some students notice it's actually very, very similar to the one we prove triangles congruent. But please pay attention. Triangles congruent meaning all 3 pair of corresponding sides are congruent. But here, in similarity, we saying 3 pairs size, they are proportional, so very different. So in order to be different, I'm going to write down this is SSS similarity. So that's a second method. So in this video, we are going to introduce the first 2 methods. And in the second video, in the following video, we are going to practice and check some examples to see how do we actually use in this method to prove the triangle similar. Yes, some students don't notice I mentioned we have 3 methods. Yes, in the future, we are going to introduce the last method, but today, please pay attention to these 2 methods. Let's say we are going to move on to the second video very soon. See you there.